video number 6 of Unit 1, titled Intermediate Value Theorem. So as we study calculus, we will study several different theorems. The first theorem of investigation is the intermediate value theorem. Intermediate meaning between. So let's write this theorem together. The intermediate value theorem states that if f of x is continuous on the x interval a to b. So we're also going to sketch this as we write it so that it's a little bit more visible. So let's say we have a continuous graph. There's no holes, there's no asymptotes. And on the x-axis, we have some values a and b. And f of a less than y, which is less than f of b, or f of a is greater than y, which is greater than f of b. So basically what the set is saying is f of a would be this y value, f of b would be this y value, so we have y values in between f of a and f of b, or if, for example, this was an increasing graph, f of a would be down at the bottom, f of b would be up at the top. Then there's this at least one value x equals c on a, b. So some value of c between our x's a and b. So notice that these are parentheses, not brackets. C cannot be a or b. We're talking about in between. So let's say c is here. Such that f of c equal to y. So remember that we said that y is going to be in between the f of a and f of b, right? So we're basically saying that if our graph is continuous, then on the interval a to b, there exists some c value where if we were to look at our graph, that f of c would be between our f of a and our f of b values. So basically there's a point in between a and b where the y value is going to be in between the y values of a and b. So now we're going to investigate the graphs below to determine if the theorem is applicable for these functions on the specific intervals. So our first graph, we have f of x is equal to this piecewise function, and our break is at x is less than -2 and x is greater than -2. So our first question is there a value of c on the interval -5 to 2 such that f of c is equal to 2? So we're on the interval from -5 to 2. So one thing that we can do to answer that question is we can draw some barriers so that we can see what we're looking at. So we're saying that between these two x values, is there a c value where our y is going to be 2? So if we look, yes, there is a c value where our y will be 2. So yes, c is somewhere between -5 and -4. Right, so our c is going to exist somewhere between -5 and -4, which is within our interval. So now we want to see if IVT, another way of saying intermediate value theorem, guarantees, okay, this is an important word, guarantees a value of c such that f of c is equal to 2 on that interval. So the very first sentence of IVT says that if f of x is continuous on the interval. So if we look at this interval, we're looking between -5 and 2. Our graph is not continuous on that interval. So just from that first statement, we can say that no, the IVT does not guarantee a value of c on the interval -5 to 2 because f of x is not continuous on that interval. So although there is a c that exists, it exists regardless of IVT. IVT did not guarantee that that would exist because this is not continuous. All right, so now let's look at the second one. We're looking at the same graph, but now we're looking at a different interval. We're looking at the interval from -1 to 5. So from -1 to 5, we're looking to see if there's a value of c such that f of c is equal to 2. So here's 2 up here. This graph never goes up there. So the answer is no. All right, so now, looking down at the bottom, we want to see if IVT guarantees a value of c such that f of c is equal to 2 on that interval. So again, with this word guarantee, right? So IVT states that if we're continuous on this interval, which our graph is, there's no breaks, there's no asymptotes, we're good to go. So we are continuous on this graph, then there should exist an f of a, and if we continue this graph, some f of b. Okay. So IVT basically says if you find f of a, you find f of b. If you were to draw some sort of box, then everything within that box, IVT is guaranteeing a y value will hit. Within this box here, there is no y of 2, y equals 2. So no, IVT does not guarantee, that's not how you spell that, such a value of c on -1 to 5 because f of c equals 2 is not between f -1 and f of c. Right, so the y value of 2 is not in between the y value when x is -1 or the y value when x is 5. So next page, what conditions must be true to verify that we can use the intermediate value theorem? The first condition is that f of x must be continuous on a b. On that interval, f of x must be continuous. The second condition is that f of c must be between f of a and f of b. Right, so that y value that we're looking for must be between the two y values on the ends of our intervals. So for each of the following functions, we are going to determine if the IVT is applicable or not, and state why or why not. If it is applicable, we're going to find the value of c that's guaranteed to exist by the theorem. So we are going to do let's say we'll do two problems. So for number one, and actually for number two, we have the same equations. So we have a rational function. So if you think of a rational function, rational functions usually have two parts to them. They usually go like this and like this in some way. So there is some discontinuity in that graph. We have to figure out where that discontinuity is. Good way to do it, find when that denominator equals 0, because that's where you know the vertical asymptote will be. So for the first part of using IVT, we need to make sure that it's continuous on that interval. So f of x is only discontinuous at x equals 2. Right? If you plug into the denominator, you'll get 0, so you'll have that vertical asymptote. Oops. So now -2, +2. So -2, however, is not within this interval. So because -2 is not within this interval, that means that f of x is continuous on that interval. If -2 was within that interval, then f of x would not be continuous and we would just stop there. IVT is not applicable. It doesn't mean that there isn't some f of c that equals 2/3. It just means that we cannot guarantee it. So we're just going to not even try. Right? So because it's continuous, we know it's continuous. Now we need to figure out what our f of a and our f of b are. So we have f of -1, which is going to be -1 minus 3 over -1 plus 2, which is just -4. So that's our f of a. And then we need our f of b, so the other endpoint, which is going to be 3 minus 3 over 3 plus 2, which is just going to give me 0. So our second requirement is that f of c must be within or between f of a and f of b. So 2/3 is not between 0 and -4. So f of c equals 2/3 is not between f of -1 and f of 3. Therefore, the IVT is not applicable for f of c equals 2/3 on the interval -1 to 3. Now, if f of c were, for example, -2, right? -2 is between 0 and -4, and we could probably figure out what that c value would have to be. But because it's not in between, because 2/3 is not in between -4 and 0, we cannot use IVT to guarantee that there exists some value of c. Okay, so you do something similar for number 2, and we're actually just going to move to number 4. I'm sorry, number 5. So for number 5, we have the function, an exponential function, -1/2 to the negative x plus 3 minus 2, and we're on the interval 3 to 5 for f of c equals -4. So our first piece is to figure out if we are continuous. We figure this out by the type of function that we have. So this function is exponential. Exponential functions are continuous for all real numbers, for all real x values. So f of x is continuous on the interval 3, 5 because it is exponential. And all exponential functions are continuous on the interval -infinity to +infinity. So just by knowing what kind of function we're looking at, we just answered the first part. We know it's continuous. So now, for part 2, we need to figure out what our f of a and our f of b are. So looking at the beginning and end of our intervals, so f of 3 is going to equal -1/2 to the -3 plus 3 minus 2, which is equal to -3. And that's my f of a. And then my f of b will be f of 5, which is equal to -1/2 -5 plus 3 minus 2, which is going to give us -6. And now our actual f of c is negative 4. Negative 4 is between negative 3 and negative 6. So f of c equaling negative 4 is between f of 3 and f of 5. Therefore, IVT is applicable. So what that means is that now I can just plug in C and use that the equation should equal negative 4 to figure out what C would be. So we know that negative 1/2 to the negative C plus 3 minus 2 should equal negative 4. So now we're just going to solve just like we do algebra. So negative 1/2 to the negative C. All right, the closer I get to the bottom of my computer, the more wonky my pen gets. So negative 1/2 to the negative C plus 3 equals negative 2. 1/2 to the negative C plus 3 equals 2. Now to get rid of an exponent, the base of an exponential function, we need to take the log of both sides of our function. So we'll take the log base 1/2 of both sides. Now we'll cancel out the half. So we have negative C plus 3 equals log base 1/2 of 2. Log base 1/2 of 2 is equal to 1. So we have negative C plus 3 is equal to 1. So negative C equal to negative 4. So C is equal to 4. So the C value equals 4, which is, if we go back to the top, between our interval 3 and 5, which is great. And that is basically how you use IVT to prove that there exists some C value within an interval that fulfills whatever Y value you're looking for. So try 2 and 4 on your own. I can tell you now that one of them does work for IVT and the other does not. Figure out which is which and figure out your C. At this point, we've done all the work necessary for quiz 2. The problems that you should be working on the homework go up to problem number 69. So get through those to prepare for quiz number 2.